we're going to take a look a little bit more about the zeros of polynomial functions and what their multiplicity is, and then finally taking a look at the behavior at those zeros. So we have this function x cubed minus 5x squared minus 6x, and we're just trying to figure out what the zeros are. And what we're going to do is we're going to factor it. And so we can start by factoring out a greatest common factor of x, right? And that's going to leave us with x squared minus 5x minus 6. And then the last thing we're going to do is we're just going to factor the trinomial. We need two numbers that multiply to be -6 but add up to -5. And so this is a common mistake that students make. They'll try something like -3 and -2, which if we don't go through and add up the middle terms, this would be -3x and this would be -2x. But unfortunately, when we multiply these together, that gives us a +6, and we're looking for a -6. So unfortunately, that's not the right pair. But we can't forget that 6 and 1 are factors that multiply to be 6 as well. And so maybe we try x minus 6 and x plus 1, and then we multiply the inner terms for -6x, the outer terms for 1x. So that adds up to -5x. And then if we multiply these, that gives us a -6 on the outside. And so that's going to be the magic factorization for this. Okay, so our zeros for this function are when we set x equals 0, x minus 6 equals 0, and then x plus 1 equal to 0. And so the solutions are x equals 0, or the zeros, x equals 6 by adding 6 to both sides, and x equals -1. And I also want you to notice that the degree of each of those factors is 1. Right, so this is like x to the first, this is x to the first, and this is x to the first. All right, and so that means that the multiplicity for all three of those is going to be 1. And so finally, we have our zeros. All right, so we have x equals 0, we have x equals 6, and we have x equal -1. The multiplicity of each of those is going to be 1. Right? Because again, the exponents are 1 for all of those. That's a y there. And so that means at all of these, we're going to cross through the 0. Okay, so the behavior is that the function will cross through the x-axis at each 0. And just to verify that, of course, we should graph this. Okay, so remember our function, we had x cubed minus 5x squared minus 6x, right? And remember we had our three zeros. We had -1 crosses through, 0 crosses through, and then 6 crosses through. All right, so of course it supports what we initially suggested. Okay? Another example, we have 2x to the fourth minus 18x squared. Once again, we're going to start by finding the zeros, and that means we're going to factor this. So it looks like I can factor a 2x squared as a greatest common factor for this function. Right? And so when we factor that out, and let me just say that this is equal to not f, but g of x, excuse me. Right? And so when we factor that out, we're going to be left with an x squared minus 9. Right? Now, we're not done factoring this because we can factor this x squared minus 9 as a difference of perfect squares. And so that would give us x plus 3 and x minus 3. Remember, when you have two perfect squares in a binomial and subtraction, it's a difference of perfect squares, a plus b, a minus b. And so our zeros are going to be when 2x squared equals 0, and then x plus 3 equals 0, and then finally x minus 3 equals 0. And notice that these have a multiplicity of 1, but this one has a multiplicity of 2. Okay, so that has a multiplicity of 2. And so when we solve these out, we would divide by 2, and then we would take the square root of both sides, so x would be equal to 0 with a multiplicity of 2. This would be x equals -3 and x equals +3 with a multiplicity of 1. Okay, so again, we have our table, we have our 0, and we have x equals 0, x equal 3, x equal negative 3. Doesn't matter which order. Multiplicity is going to be 2, 1, and 1 respectively. And remember, when the degree or the multiplicity is even, that means it's going to be a turning point. It's just going to turn around exactly. So at that 0. So for our behavior, it's going to turn around at x equals 0. And then it's going to intersect and it's going to cross through where x equals 3 and x equals negative 3. Okay, and we should specifically say cross through the x-axis at x equals to, positive and negative 3. And of course, we want to verify this by graphing it. Okay, so let's go back to Desmos and graph this thing. And if we do so, remember our function was 18x to the fourth minus 2x squared, right? And or maybe it was the other way around. Excuse me. It was 2x to the fourth minus 18x squared, right? And if we zoom out some, not a lot, because it does have like this really low behavior down here, but notice right here at 0, it turns around, okay? And these are the points positive and negative 3. It crosses through the axis there. So once again, even though we suspect our answer, we probably want to graph it, but we should be able to do it without graphing. Okay. Now, finally, we have this animal right here, this x to the 6th minus 2x cubed minus x to the 4th. And this is a pretty sneaky one, just because the factorization is a little bit tougher than the others. Okay, so first things first, let's factor out the greatest common factor. So our greatest common factor is x squared. And if we factor out the x squared, that's going to reduce the order, or x to the 4th, excuse me. So let me erase this. So we factor out x to the 4th, and that's going to reduce each polynomial by an order of 4. So this is going to be x squared minus 2x plus 1. And of course, if you don't trust your factorization, remember, factoring is just the inverse operation of polynomial distribution. Okay, so if we want to distribute, we could check. And then the last thing we're going to do is we're going to factor this trinomial. And so p of x is going to be equal to x to the 4th. This would factor into x. We need two numbers that multiply to be 1, and the only numbers that multiply to be 1 are 1 and 1. And if we wanted to add up to negative 2 in the middle, they both have to be negative. But notice that these two factors are exactly the same, and it's not completely factored. And so what we would do is we'd write this one more time as x minus 4, x minus 1 quantity squared. And now we can see that there are two multiplicities of degree of order higher than 4, or higher than 2, excuse me, or higher than 1. So this has a multiplicity of 4, and this factor has a multiplicity of 2, because that's what the exponent is on both of those, right? Now we set them both to 0, so x to the 4th equals 0, and then x minus 1 squared equals 0. If we were to take the 4th root of both sides, we would still get 0, so x equals 0. And then over here, we take a square root of both sides, x minus 1 equals 0, and then we add 1, so x would be equal to 1. And keeping in mind the multiplicity, our two zeros are x equals 0 and x equal 1. The multiplicity is going to be respectively 4 and 2. And then finally, the behavior for both of those is because they're both even. Okay, so the behavior is right here at x equals 0. The graph is going to turn around. At the x-axis. Okay. And then over here, it's going to do the same thing at x equal 1. It's going to turn around at the x-axis. Okay, so let's one last time graph these functions, okay, just to make sure, or graph this function, and just make sure that it follows that behavior. Okay, so we have x to the 6th minus 2x to the 5th plus x to the 4th. All right. And I want you to notice that right here at 0, we have a turnaround. This point is really just going to be like a local maximum. And then at 1, it turns around again. Notice it never crosses the axis. Okay. And that's exactly what we should expect, is that it never crosses through because there are no zeros of multiplicity of odd degree. So that's one way that we can start predicting some of the behavior of these polynomial functions. Okay, so now we know the far right, far left behavior by looking at the leading coefficient and the order of the polynomial, and then we also take a look at the zeros, and we can start kind of getting an idea of the behavior of the graph at those zeros. So in the last set of videos, what we're going to do in this section is we are going to put all that information together, and we're going to be able to try to graph these polynomial functions without utilizing a graphing device. But of course, we can check the answer by using our graphing device at the end.